Hi, I'm Vishal Karthik. I'm a senior Gen AI developer, and I'll be talking about AgentCore Memory today, which is a preemptive of AgentCore, a Bedrock service that AWS launched a couple of months ago. It enables standard LLM models to become complete agentic AIs, and we're going to be talking about AgentCore Memory's role in it, which is to convert these inherently stateless LLM models into stateful agents by providing them with a smart memory store. I've built a culinary agent and used a couple of concepts from Agent Core Memory. So I'll dive into it and explain how it works. So today we're going to be talking about the Culinary Assistant program that I built to showcase Agent Core Memory's features. So the goal is to make this assistant remember your food preferences and use them later to give you personalized restaurant recommendations. So the concepts involved here are short-term memory, long-term memory, and memory strategies. I'll get into that. But before that, we first set up perfect. I've already set up my AWS account. I set the region to US West 2. We've downloaded all the relevant SDKs, Strands, AgentCore Memory libraries. So then we move to the memory creation part. So yeah, before we do that, let me just give you a quick intro. So there are two types of memory involved while managing an agent's memory. There's the short-term memory, which involves conversations, or here they call it events, the back and forth between the user and the agent itself, the raw data. This is managed through external data from the agent, right? This is something we get from the conversations itself. Long-term memory, however, is something that's extracted later from short-term memory based on these things called strategies. Basically, strategies specify what and how to extract these insights. Insights being preferences, being summaries, or anything like that. These are all pre-built, of course, and Agent Core allows you to add custom strategies, to extract particular insights from the conversations, leaving the rest out, because preferences cover a lot of things, also summaries. So if you want your summary taken in a certain way, you can opt custom strategies too. So this is managed by Agent Core Memory, and the extraction happens in a sort of eventual consistency format. So once STM is populated, LTM starts generating. It needs some time, however, but according to your strategy, it happens continuously as events gets fed to the short-term memory. So we'll have to initialize that. So there's the memory client. We've named the memory Culinary Assistant. We initialize the memory with the strategy user preference, because we only want the preferences from the users, and this is not exactly bound to these three. It can be any preferences. So once we run this, we'll let that run. There's also namespace involved for the session identifiers, because actor ID is essentially the user ID. Session ID is to identify this individual session. Doesn't matter too much here since we are not actually isolating sessions. It's just two different sessions over here. And the namespace is essentially a representation of how your memory is categorized. Over here we can see that it's preferences that's categorized into separate folders based on the user ID. So each user has their own preference, sort of like that. You can set up your own namespace. I mean, since we're isolating memory by user, we've chosen this. If you want an organization, you can go another level deep. If you want it separated by, sessions, session ID also can be involved over here. So is it done? We'll let it run and go ahead. So once that is created, we hydrate the short-term memory. So as you can see, until now we haven't set up an agent yet. So we're not going to do that until there's a memory already loaded up. So to simulate a previous session, a previous conversation, we've done this. We've taken this example. So it's just a back and forth between the user and the assistant. The user asks for recommendations. The assistant asks for the preferences from the user. They say they like Italian, they enjoy Thai restaurants, and the assistant asks about the budget for the dine out. They say it's $15 to $30 per person, and they like mid-range restaurants. So these are all examples of preferences that LTM might absorb, extract. So over here, what we do is we use this create event method. Once again, to the drawing board, we are using a memory tool to extract, to not only extract, to converse to AgentCore memory. There are multiple tools, but we're going to cover the memory tool now. There's also hooks that you can use, which is more customizable, but we're going to use memory tool, and we're going to give it to the agent itself to use it whenever it feels right. So initially we're going to use the create event tool to store events. Event as in the conversation, the short-term memory conversation, the back and forth, the array of back and forth we have. We're going to use that. You know what? Let me go ahead and the ID is created. Let me run this. Perfect. Run this too. Conversation is initialized. Then what we do is create this event with all the conversations. Pretty straightforward. So this takes no time, absolutely instant, because the STM is just a memory storage, a conversation storage. Then we move to retrieving long-term memories. This needs time because we've just uploaded our STM. I give it 120 seconds to be safe. It usually happens much quicker, at the max 30 seconds, but me using US West 2 from a different server, so I give it more time. So we let that run. As I told you, we create events, we upload the data into STM. So the STM is now populated. We give time for the LTM to get populated, and it's just a query. This is simple. What we do is, let's assume LTM is populated. LTM has these insights. Now we move to the agent. So there is an existing memory. Now the agent would leverage that to gather personalized preferences and respond accordingly. So there's a system prompt. You will have to include this though, memory tools, because the agent doesn't really know it has the memory tools. These memory tools to be exact. So there's the record. It records a new memory, kind of like a create event. There's a retrieve. It extracts the appropriate memory from the LTM, because LTM should have a lot of preferences involved, but we really want only the ones relevant to the prompt the user has given us. So it uses semantic search, so the agent can really craft a prompt to request, and this tool will get you the relevant memories. There's the list. It's just to go through the memories to get specific memory by ID, and this is to delete a memory. So let's say I'm not the user goes, I'm not vegetarian anymore, I'd like to try non-vegetarian. Or if the user doesn't like Italian anymore or doesn't want to indulge in Italian anymore, this will help the agent to alter the memory. So we don't use all of that over here. We just give it access to retrieve and maybe also add. Yep. So over here you can see that we initialize the memory tool provider with the memory ID, actor ID, session ID, and the namespace that we defined earlier, and we create the agent with the tools from the memory provider. I use a 3.5 Haiku model. It's enough for this experiment. So have I run this? Okay, yeah. This is the LTM that's being was generated with the price range of restaurants being $15 to $30 that it got absorbed. What else? Vegetarian, that's a preference, and it also added a category, right? There's the budget, there's the dietary restriction, the dining experience, the cuisine, and this will help while retrieving data using this tool. So while semantic search, the agent might use what cuisine does the user prefer or something like that, and all these two memory will be returned to the agent. So yeah, once we're done with this, we initialize the system prompt, we initialize the agent. All right, now that's done. Let's test it. We ask for a response from the agent. Brilliant. So we ask for restaurants in San Francisco based on our preferences, but we haven't given any preferences after we've created the agent. As you can see in the response, it uses the tool that we've provided, the AgentCore Memory library, and we are not sure exactly which tool it uses because we don't have access to that. It's abstracted, but you can see that it found out that I like, not me, the user likes Thai and Italian cuisine. They like mid-range restaurants, vegetarian, food quality. These are all preferences by the user, and it recommends restaurants in San Francisco. Perfect. Now another response. Again, it uses AgentCore Memory. Let's see what it was thinking the agent was. Okay, so for the special date, it chose to slightly go over the typical budget. That's perfectly all right. What about the last one? This kind of involves creating a new memory. This one, the record tool, it probably uses that. Yep. Again. So yeah, it adds that. It remembers this date night event too, and voila, you get your responses based on that. So I think I've been extremely clear on what happens. The memory creation, the short-term memory involving save events, the automatic extraction happening in LTM, what LTM is, and how AgentCore Memory and the agent are integrated using the memory tool provider. Next time I'll discuss about hooks and also about custom strategies that help you extract insights more precisely based on your use case. So once we're all done using that, I think we can reallocate the memory to save costs. That's it. All right, thank you.